Hey, this is Natalie Mead from Snowflake APJ. So the best thing about Discover is you could be a new user just learning about Snowpark, or you could be a data scientist that wants to build training models or think about a feature store. Who should come to Discover?
If you're a data engineer or data application engineer, you should definitely attend this session so as to actually understand how you can run data pipelines efficiently within Snowflake just using Python.
That is going to give you an end-to-end capability of how you can bring the data in. You will be able to see how you can manipulate the data within Snowflake itself, train the model, deploy the model. You can run inferencing at scale with applications on Snowflake. I'm excited. The more people, the better.
Technically still not bots, real humans.
Use the Q&A for questions and ask whichever question is important for you. It's not too late to invite your friends and colleagues to Discover. So and they will be with you shortly, so you won't be alone. With that in mind, we will also provide a lot of useful links that our experts have curated for you at the end of the session in a follow-up email. If you've joined us using a dummy email address, say helloworld@helloworld.com, we are not going to be able to share the resources with you. So if you've done that, we'll give you a couple of seconds, drop off, take 2 or 5 seconds, join back quickly with your correct email addresses so that we can send out all of the resources to you when we have them ready. As you know, this is part 2 of a multi-part series, and we told you that we are going to be doing 3 parts. We are done with part 1 last month, where we covered data lake, data warehousing. We are doing data engineering and data science. We have part 3 coming up in June on applications, collaboration, even covering aspects of monetization as well. And there is a surprise element in July. There is a mystery box right there. We are not going to give you any spoilers, but stay tuned. We might just have something very interesting for you in July. As I said, we've been doing this since the morning. Data engineering, we've covered the A to Z of data engineering workload on Snowflake. We had a great keynote by Murad. We had Sarita doing a hands-on demo on data engineering workload. We have done the concepts of Snowpark and implementing data engineering using Snowpark. And we are at the last session today. We are going to go with streaming data processing. We had a lot of questions in the last session on streaming data processing. So I hope by the end of this session, your questions are answered. If not, just use the Q&A functionality. We'll have your questions answered shortly. If your questions are still not answered, connect with us on LinkedIn. We have a whole host of speakers here. I'll introduce our esteemed speaker today, who has been captivating audiences in India, Rita Saha. But before I go there, I know there were a lot of questions that we had been getting on Snowflake certification, and we are offering a 50% discount to the first 300 users who register for Snowflake Foundations. Is essential for if you're a data engineer, data scientist, data administrator looking for a Pro Core certification, you would need a Snowflake Foundation certification as well. Scan in the QR code. I'll leave this slide on for a couple of seconds. Take a screenshot, run it through your camera, run it through your QR code scanning device, and there is a 50% discount coupon that we have running until June 30th. With that in mind, I'd urge everyone to try Snowpipe. There is a short 15 to 20 minute walkthrough that Dash Desai has created for all of you. If you're really new to Snowflake and don't want to invest a whole lot of time, just maybe 30 minutes or so, just look at the demo and look at the quick start, and you should be good to go. Now, with that in mind, and with no further ado, let me introduce and call up on stage Ritabrata Saha, who is a senior data cloud architect on Snowflake's team. He is an absolute legend at what he does, and he'll be walking you through streaming data processing on Snowflake. Rita, are you here?
Yeah, thanks for the very warm welcome, Farhan. So, yep, let's get started. So I'm going to share my screen. And here goes the presentation. So welcome everybody, whoever has been able to join, and thank you for taking your time on a weekday morning here in India. So what are we going to look at today? So this session is on Snowpipe streaming. So I heard that you guys have been listening about data engineering on Snowflake, data science and ML workloads on Snowflake, and streaming is definitely one of the very key components of each of those ecosystems, right? So today, what are we going to do? We are going to look at Snowpipe streaming. What exactly is Snowpipe streaming? When do we use Snowpipe streaming, and what are all the benefits that brings to the table? So this particular presentation is a quick 20 to 25 minutes presentation, and once we are done, we will open the forum for we'll take some questions, and soon after that we will dive deep into our demo session, wherein I'm going to take you through how to set up Snowpipe streaming, the very basics of it, and yep, and you will see me doing things in action. If you are interested enough, you can follow along with me. Otherwise, the code and entire package will be shared with you. The links will be shared with you. The quick start demo of the quick start demo, and you can take it up at your leisure. Cool. So let's get started. So I would like to start with brief overview of what data engineering in Snowflake looks like. I'm sure people who have been attending this session from the morning would have looked at this slide, or maybe different shades of this particular slide in different contexts. But then without discussing this, I think pitching Snowpipe streaming would not be right. So on the left hand side, so we'll do a left to right move. So on the left hand side, what you see is the different data formats that Snowflake supports. So here we have the structured data, we have the semi-structured data, which are JSON, Parquet, XMLs, and then you have unstructured data like the PDFs and images. So today the data cloud supports all these three formats. Now, when it supports all these three formats, definitely you need different mechanisms to push or to pull these data into the data cloud, right? And for that you have the different mechanisms, which are the traditional way of copying from any cloud blob storages. Then you have the Snowpipe, which is a serverless service. For those of you who are new to Snowflake, Snowpipe is a serverless service. But then for those of you who have been working with Snowflake for quite some time, this was a game changer for us. This was the way wherein we can let go of any third-party integrations. We can do everything natively in Snowflake, bringing files from any S3 or Amazon or Azure blob storages into Snowpipe. Now we have Snowpipe streaming in the Kafka connector. This is something which we are going to deep dive upon. And finally, you have the schema evolution and schema detection. So this particular feature of schema detection and schema evolution is still in private preview, and will be public very, very soon. Now that we have looked at what ingestion, how the ingestion looks in the Snowflake world, let's take a look at the transformation world. Now, Traditional developers in Snowflake were very much used to JavaScript stored procedures and the SQL stored procedures that Snowflake offers. Very recently, we have announced our one platform for all the data engineers and data scientists, which we call the Snowpark, wherein you can code in Python, you can code in Java, you can code in Scala or JavaScript. So this is one platform wherein all the developers, all the the business analysts can code in the same way. You see the streams and tasks. This is nothing but the way you capture your CDCs. You can do a change data capture with CDCs and tasks within Snowflake. And finally, you have the tasks, which is nothing but your serverless execution or serverless schedulers. You can schedule a stored procedure to run at a particular time. Okay, so we have dynamic tables. Now again, dynamic tables are private preview. We will deep dive into dynamic table at the end of the presentation. I do have a dedicated slide for dynamic tables, but then just to give you an overview of what dynamic tables are. Dynamic tables are a new type of tables, and you can automatically refresh a dynamic table. You don't need tasks. So we will deep dive into dynamic tables a little later. Moving on to the data delivery part. Now, as soon as your data is transformed, your business will be eagerly waiting for the dashboards to pop up, right? Now, in that case, we have our BI analytics, the data science partner ecosystem, and everything which can consume the data from all the data that is already transformed. And then if there is a requirement to share this data to another stakeholder in the same organization, or maybe to other organizations, we have our data sharing. So for those of you who do not know data sharing is a concept wherein we can move data across cloud and across regions. And the benefit of data sharing is that you don't have to do any ETL. So you might have your data in somewhere in India, in Mumbai, and you might want to move that particular or share that particular data to another stakeholder in your organization or outside your organization who's sitting on a different cloud, who is sitting in Melbourne. Maybe you can very well do that, and the consumer need not do any particular ETL. It's a live query on your data share. Moving on. So Snowflake data ingestion. So if I have to double click on Snowflake data ingestion, what exactly, what exactly is Snowflake data ingestion looking like for a developer? So it's very simple. First of all, as a data engineer, we like simple things, right? So the architecture is very, very simple. Whether it's a batch ingestion or whether it's your streaming ingestion, the entire pipeline doesn't change. It's just the way you push your data. But once the data arrives into Snowflake, it's one unified framework that handles both your batch data and your streaming data. There's no separation of streaming and your batch, right? Number two is work with streaming data easily. It just works out of the box. You don't have to, these are all serverless tasks. So there's zero admin responsibility that you have to undertake, and that makes it super simple to manage. And finally, this is all native to the data cloud. These are all first-party citizens. That means they can leverage all the Snowflake functionalities. So on the slide, you see something written like security and governance. So if I talk about security and governance, it is very, very important for all the data engineers to understand and implement security and governance. And if I talk about Snowflake has a bunch of features which are provided out of the box to implement all the security and governance features. And because this streaming is native to Snowflake, all the security and governance features comes into action the moment you talk about streaming within Snowflake. Okay, so now let's deep dive into the different ingestion options that you have in Snowflake. On the left-hand side, you have copy. This is something which was introduced a couple of years ago, and it was used to move data which is there in your Amazon S3s or your Azure Blob storages into a particular table which is created on Snowflake, and this was this was efficient while you are moving bulk amount of data. So you can have gigabytes of data lying on your blob storages, and you want to try and load it to your clouds tables. This is what comes into action. Next came in the Snowpipe. So this is more of a continuous ingestion. So you don't have to I don't know, monitor the moment a file arrives and then fire your copy command. This is something which can be set up in the background, which it is always listening to your cloud storage. Whenever a file arrives, it pushes the file to your cloud or to your Snowflake tables. Now, this has a median latency of less than 30 seconds, and this was again, this is a serverless feature. Now, with those two predecessors, now come in the Snowpipe streaming, which is a near real-time ingestion of rowsets. So both copy commands and the Snowpipe streaming, they were file dependent. So that means you have to create a bunch of files, put it onto an S3 location, before Snowpipe pushes it to the particular table. But then with Snowpipe streaming coming into the picture, we are getting rid of all the concepts of a file, and we have brought in the concept of a rowset. Now we are going to dive in and look at what rowsets look like. But before that, this particular mechanism of pushing data from your streaming components has a median latency of less than 5 seconds, and this is what is making it so popular amongst our customer base. Yeah. So what are the different use cases for streaming? Number one is a connector. So whenever I talk to a lot of my customers who have their data on-prem, so it can be a SQL server, it can be an Oracle machine, it can be a MongoDB instance, they keep asking me that, how can I move that particular data to the data cloud, to Snowflake at real time? Now the answer is Snowpipe streaming. You can set up Snowpipe streaming on your on-prem systems. Whenever anything changes on your on-prem system, that particular change data is captured, and if you can push it to Snowpipe streaming, it immediately reaches your Snowpipe, your Snowflake table in no time. Right. The next use case is your Kafka streaming or your Kafka or Kinesis sources. So if most of the enterprise customers have an enterprise bus in the format of a Kafka, right? So anything that is published into Kafka can be consumed with Snowpipe streaming and pushed into Snowflake at real time. Then we have our log analytics. So for all the cybersecurity experts in the room, if you are planning to set up a cybersecurity workload or a cybersecurity data lake on Snowflake, you definitely have a question: how quickly and efficiently I can get all the cybersecurity or all the logs that all the servers are generating into Snowflake. Snowpipe streaming is the answer for it. And finally, I have the IoT devices. So very recently, we have launched our manufacturing data cloud, and we had a bunch of customers over there asking a question that on my manufacturing floor, if I have multiple IoT devices generating the data, how quickly and efficiently can I take that particular data set onto the onto the data cloud? Again, Snowpipe streaming is your answer. There are two different variations of Snowpipe streaming. We will look at it. You can set up you can set up the streaming ingest into an SDK, put it onto your edge device, and start pushing data to the Snowflake. We will look at that. How do we do that in some time, right? Now that we are done discussing some of the use cases, now definitely this is not a comprehensive list, but these are the ones which are very, very common whenever we start interacting with the customer. Now let's look at a high-level summary of what Snowpipe streaming will look like, right? So I'm not going to go through the content on the slide, but then that's for you to read through. But hear me out while you are reading this one. So Snowpipe streaming is a low latency framework, right? So it's not real time, it's near real time definitely, and it has a less than 5 seconds latency. So that means the moment data is generated at your source, within the next 5 seconds, you can take it to your target, which is your Snowflake streaming. Now, why is it very, very important? Because most of the customers, whenever we are talking, they are very interested to take data to the data platform as soon as data is generated at the source. So whether it might be some logs out of a server, but it can be some signals coming out of an IoT device, or maybe some database changes which are going on your on-prem systems. So they are very interested to take that particular changed data to your data cloud as soon as possible, and Snowpipe streaming is going to do the job for you. Now, why is it very easy? Because it's a serverless task. You can set it up with very minimal configurations. We are going to see that in the demo how easy it is to set it up. It is a serverless task. There are few parameters based on which you can estimate the cost, like your number of clients, your volume of the data, your data types. So these are the very few parameters based on which you can estimate the cost of Snowpipe streaming the serverless compute, right? And on the right hand side, you can see there are two ways that how Snowpipe streaming can work. Number one is your streaming ingest SDK. So this is a Java SDK. This is made open source. There's a GitHub repository. You can go ahead and download that. I'm going to share that link after the session. So you can build that SDK and you can host that SDK onto your Docker containers wherever you want. It can be your local machine, it can be your servers, it can be your edge devices, and that makes very easy for the customer to hand over the data that is generated at the source to the streaming ingest device, right? Because you can host it in a Docker container anywhere. The next way to work with Snowpipe streaming is the Snowflake Kafka connector. So in case you have a Kafka and your devices or your logs are getting published onto your Kafka system, you can configure the Snowflake connector and make the data reach your Snowflake target in no time. Now, Snowflake Kafka Kafka connector and Snowflake streaming, they are very similar, but though they are not the same, we'll look at what they are, right? Okay, so when we were talking to customers, the challenge was they wanted to keep their business informed. Business was super curious to find out what is going on their the business the business side of it. They wanted to create real-time dashboards. They wanted to create insights as early as possible, and that is the core reason why they wanted data in the data cloud as soon as it is produced. And Snowpipe streaming is the answer to that. Now, the moment I talk about streaming, another question that we often get from our customer that, do I have to manage it? How expensive it is? And if my number of sources increase, or if I have a sudden burst of records coming in on a big weekend sale, is this particular framework going to scale? The answer is yes for all those pointers. It can scale on its own. It is super cheap, and it is serverless, right? So that means you have zero admin tasks, right? I think we have already spoken about the future benefits and business value. Let's move on. Okay, so here we compare the Snowpipe, the traditional Snowpipe, which was which has been announced maybe a couple of years ago, and Snowpipe streaming. So why do they exactly differ? Now, Snowpipe, as I was talking in the beginning, Snowpipe is file based. So you hand over a file to your S3 location, excuse me, to your S3 location. Snowflake identifies that yes, there's a file, and it pushes that particular file into Snowflake. So this is a time consuming task because a process has to listen to the arrival of a file. It has to react to the arrival of the file, right? So on the left hand side, there are few pointers which talks about Snowpipe. So that means deduplication with file tracking. Yes, this was something which is great, because if you have same data coming in the file, it does do a deduplication. You can configure that. It's concurrent, but then it's unordered. That means if you have multiple files coming in, the ingestion within a file, so records within a file are definitely ordered, but then the order at which a file comes and the order at which the files are loaded, they are not the same. So you can have 1, 2, 3, 4, 5 coming in, wherein the loading process can be 1, 3, 2, and 5, right? and it had a 30-second median latency. Now, while most of the customers were happy with this kind of a latency, but then there were many other customers who had different use cases wherein they were talking about, where they were talking about bringing in data at real time. So that is where Snowpipe streaming comes into the picture. This is a public preview feature. That means if you have set up a trial account, you can try it out yourself. So now, how different is Snowpipe streaming from the Snowpipe? So Snowpipe streaming is based on rowsets. So as I move data from my left to right, from the point of ingestion or from the point of creation to my target, I completely avoid the concept of a file. I am now looking at rowset, which is nothing but a set of rows. I can control how the rowsets will be, how the rowsets are to be defined in my configuration file, which we will look at during the demo. And once data is coming into that particular Snowpipe streaming process, it is ordered. This gives you a throughput of about a gigabyte per second on a single table. And this typically has a latency of less than 5 seconds. Okay, so we looked at some brief differences between Snowpipe and Snowpipe streaming. Now here is how the Kafka connector and the Kafka connector for Snowpipe streaming works, because the Kafka connector, as you see, is using Snowpipe in the background. So the Kafka connector was there for quite some time. Now Kafka connector is using Snowpipe in the background. So what it means is, on your Kafka, if you have multiple partitions on a particular topic, and you are moving the data from all those topics to your target table, the Kafka connector listens to all these topics, all these partitions, and creates very small files, and maybe the file size maybe in KBs, but then it does create files for each of these partitions in an internal stage, and from there Snowpipe picks it up. So Kafka connector internally uses Snowpipe. Now, while this was great, but then we were not able to address the the near real-time requirements which some of the customers had. With Snowpipe streaming coming into the picture, the concept of a file and internal stage has been taken out, which has been replaced by a new concept called channels, and every channel is mapped to a partition. So if your Kafka has let's say 4 partitions in this case, or it can go up to, we don't have a hard number, because most often when I speak to my customers, there's a question that is there a hard limitation on the number of partitions that you have? No, we don't. But then we often recommend that the best solution comes, or the best throughput comes when you try to limit it below 16. But then if you go above 16, the system is not going to break, but then your the best throughput you may not achieve it, right? So you have your partitions. Every partition is connected to a particular channel, and Snowpipe streaming pushes the data through the channel into this particular table. So the entire concept of files coming, the files have been taken out, and each channel operates on a set of rows, and this makes it super fast. Looking at Snowpipe streaming, so it's a direct data streaming, ingestion of tables over HTTPS, and we don't have any files to manage. It's exactly once per channel. That means you don't have to worry about duplicate records coming into your particular table, right? It's low latency, it's high throughput, gigabytes per second. It's very low overhead, so you don't have to worry about management of this particular serverless topic at all, of the serverless compute at all, and it's very, very low cost. So in the beginning, if you remember, I was talking about some of the key factors which you should consider while estimating the cost, which is your number of clients that you have, your number of records that you're pushing, and the data types, and at the same time the size of a particular document or a size of a particular record, right? So they all act towards finding out the the final cost for your this particular service. Kafka connector with Snowpipe streaming. This is again open source. It is streaming exactly once. You can configure your error handling in a dedicated queue. It is low cost, low latency, and it does support schematization. So schematization is something which is in private preview today. Today, the moment we will get into our demonstration, you will see that on the target table there are two columns that are created. One is your row content, and one is your row metadata. So row content is one big one big column with the entire JSON record that, or maybe a string that you are ingesting into that, right? But if you enable schematization, you can split that up into particular columns. So for today, the account that I'm using that doesn't have it enabled, but then it is going to be in public preview soon, and you can try it out for yourself. Okay, so yeah, here is dynamic table. So data coming in from your sources and moving towards your target, this is fine. But then you'll have to refresh your sources. So there's a table wherein a lot of records are coming in, right? Streaming ingestion, that means we were talking about a gigabytes per second. But at the same time, this particular data which is coming in at near real time has to be consumed in multiple pipelines. So in the traditional Snowflake world, how would you have done it? You would have created a streams and task, which is a stream listening to this particular table wherein data is coming in, and you configure your task, which can execute at every minute. But then this was becoming a little difficult for the developers to manage so many tasks and streams in your entire data pipeline, right? For that reason, we brought in a new concept, which are new table type, which are called dynamic tables. Dynamic tables can be configured to listen to a particular source table, and it can refresh on its own, right? So and you can create a DAG of, so on the right hand side you can see a DAG created of multiple dynamic tables, right? So a dynamic table can be created with multiple dependencies, and that gives it the benefit that you can create multiple DAGs out of it. And these DAGs can be visually, you can have a visual representation of those DAGs as well. Now for our demo today, this is not something that I can show it to you because this is a private preview feature, but then the moment it becomes public, I would request you to go ahead and try out the hands-on labs on dynamic tables. Right. So we are done with the the theoretical part of it. It's time to dive deep into the demo setup and get it working. Now here is a quick pictorial representation of what are we going to do in the particular demo. We have set up a local environment wherein I am running Kafka, and within the same Kafka process, this is a standalone Kafka. So within the same Kafka process, I have Zookeeper, I have the broker, the producer, and the consumer running. And once I produce the data within this particular Kafka, the Snowpipe streaming will be configured. The Snowpipe streaming will listen to that particular published message, and it is going to push it into Snowflake. This is a very simple setup, and we are going to deep dive into this. But then before I go there, are there any questions that we are looking at? Let me go to the question answers. I'm looking at the questions. Okay.
Let me help you, Rita. There have been questions where folks have asked, like, what is the difference between Snowpipe and Snowpipe streaming, which you already covered, but there are a couple of questions there. And also there are questions around APIs. How can we build APIs and still have our data processed, and how does it differ now from the earlier areas where we did not have streaming? So although two different topics, but yeah, questions on them are very common.
I think how Snowpipe and Snowpipe streaming differs, I believe I have spoken a lot about it. So Snowpipe was a feature which was using files in the background, and that is why we had near about a 30-second latency. But then with Snowpipe streaming coming into the picture, the entire concept of a file has been moved out, and we have brought in the concept of a row set. So that means, and you can define those row sets, right? So that means the way the data, the pace at which data comes into Snowflake is much higher than Snowpipe, right? And there was a question around APIs which I really couldn't understand.
It's okay. There's another one which is very popular,
okay.
Rita, which is what is the difference between dynamic tables, materialized views, and normal views on Snowflake?
See, normal views are simple database views. You can have a table, and on top of it, you can create a view. You can do a select star on the view. You can write a complex SQL query, which we can extract as a view. So the view doesn't store a data. A normal view is not a store of data. So it's on demand. The view, the query behind the view comes into action the moment you execute the view, right? But then materialized tables are and dynamic tables, they're pretty much the same. So you can create a dynamic table. You can say that the dynamic table can be refreshed, has to be refreshed, and at this particular frequency. And you can write a query within the dynamic table, and what it does is this particular query gets executed on the source of the dynamic table at that particular frequency which you define. Right. Any more interesting questions, or we are good to dive deep into?
Yeah,
okay.
they are good to
In
dive
case
deep.
of Kafka connector plus this is one partition, one row set by default. Okay. So the relationship is between the partition and the channel, and one channel can have multiple row sets, right? So if you have multiple partitions, you will create the system will create multiple channels on your behalf. We will see how many channels gets created over here in our demo setup, and in that particular channel, multiple row sets can come into the picture, right? Because when you are publishing message to a Kafka topic, you mention the partition on which you are publishing that particular message, right? And the moment you mention the partition, that means that particular message flows from that partition to the channel and to the particular table. Is dynamic table incremental or it's a full load? Yes, it is definitely incremental. How do the retry logic for Snowpipe streaming with Kafka partition? How do the retry logic? Yes, it does a retry. You don't have to do anything. It is all out of the box. Exact use cases for dynamic tables. Exact use cases for dynamic tables would be create a chain of pipelines. So let's say if you are an ETL developer, you would be keen to pull the records which are coming into your streaming source. So you create a dynamic table to pull data from your streaming source, and then the moment the streaming data arrives, you might want to do some a data cleaning activity. Now the data cleaning activity can be a bunch of queries running as a dynamic table, and you can pass on the data coming in from the source through that cleaning process, and finally you have some joins. So all these different stages can be each of one dynamic table after the other, chained together, working in a sequence. Okay, we'll look at the questions again at the end. For the time being, let's dive into the demo. Okay, so on my screen, you can see a quick start from Snowflake. So you can log into quickstart.snowflake.com. You can search their streaming data integration with Snowflake, and this is the page that you will land up into. Now, for today's session, we are not going to go deep into all these 8 sections because we are primarily concentrating on Snowpipe streaming for today. Snowpipe is something which, if you are aware, well and good. If you are not aware, if you are very new to Snowflake, I would request you post the session, please, review this particular quick start for yourself. For Snowpipe, it has, a detailed code and the detailed execution strategy and detailed benefit of what exactly Snowpipe is offering you. How do you make it operational, and what exactly is the latency that Snowpipe has to offer? Please, dirty your hands and get along and have a taste of Snowpipe. And then immediately after that, you will understand what is the benefit of Snowpipe streaming. So I'll tell you, for those of you who are new, this is phenomenal. So if you're moving from Snowpipe to Snowpipe streaming, you will see, things changing. It's like, it's just a magic. So when data used to come to you with 30-second latency or maybe a minute latency, and now it is coming in seconds, this is super impressive, right? So so point number 1 to 5 is something which I'll leave it to you to follow along maybe at the end of the session. But for now, we will start looking at Snowpipe streaming, right? So what are the basic set of factors? So what we have done is on my laptop, I have set up an open source Kafka. I'm going to show you how did I do it. We have set up the Snowflake Kafka connector 1.9.1. That's a new version. We have OpenJDK, which is less than version 15. For my machine, I think, for those of you who can see my screen, I think I have, I have version 11. So this is what is working, but then you can try with an most updated version as well. I'm going to look at the Snowflake setup, and we'll look at how the Snowflake setup looks like. And then I have the code for the Kafka connector setup. So what they're doing is they're creating a folder, moving to the folder, and they're downloading the Kafka binary. They're unzipping it, and then they are downloading the Kafka connector from the Maven repository. So just for your understanding, I have opened up the Maven repository over here. So you see Kafka connector, and you have the 9.x. For this particular demonstration, we are going to use 9.1. 9.2 is already, it's just a recent release. 9.1 was released sometime in the month of March, right? So this is what this entire query is doing. And then we have the property file setup. So that's fine. I'm going to enlarge my screen, and I'll take you through this. All right. So where am I right now? I'm here. So I have a folder called HOL Discover. I hope my screen is visible to all of you guys. So on the screen, what do you see? I have already downloaded Kafka. So this is the downloaded version, right? And I have unzipped it. This is the particular folder. So let's get into the folder. Let's see what is there. ls-l. So this is all the Kafka process setup, right? Sorry. Okay. Now you can see there are two files, right? RSA, there's a private key and the public key. What are these two files doing? Let's go back to the quick start. Now, on the beginning of the quick start, you will see that there's a link that, please follow the instructions to generate SSH key pair. So what exactly is the key pair we are using for? Now, this particular key pair is used to set up a communication between your Snowflake cloud and your local machine. It can be a local machine, it can be a Docker container, it can be an Amazon EC2, or it can be any other VM anywhere on any other cloud, right? Now, the communication between that particular virtual machine and the Snowflake data cloud happens by the exchange of this private and public key. So what we have done is, if I go to this particular link, which is nothing but here, right? So it clearly tells you how do you create those private keys and public keys. So this is the command to create your private key, and this is a command to create your public key. And this is exactly what I've done, right? Now, the public key goes and sits on your Snowflake user, and the private key sits on this particular VM, wherever you're streaming ingest this particular thing running. So we'll see that in action. Okay, now this is a Snowflake account. So what we are going to do, we're going to create a database, discover May 23. We're going to create a schema. We're going to create a warehouse. Now, for your information, all these statements are already available in your quick start, but then I'm just showing you from here. And then you create a particular user, which is Snowpipe streaming user, a sample password, default role is account admin, must change is false, and then the public key, right? Now, there's a trick. If you notice this public key, okay, let me go ahead and open the public key over here, RSA, public key. So here is your public key, but then you can see all these, line breaks. So when you copy this particular public key onto your editor, you have to ensure that you don't copy those line breaks. So the easiest way that I generally follow is you can copy them. You can just open your browser, go to URL, paste it over here, copy this, and Control C. Yeah, and it works like a charm. You can have different mechanisms to do that, but this is what I find it really easy to follow. So I exactly did that, and this is where the user is getting created, granting account admin to this particular user. So let's get this done, right? So this is a very basic setup where we are setting up a database, a user, wherein the target table will be set up over here. Now we're going to perfect. If I do a refresh, what do you see? There's a new database called Discover May 2023 ingest, and within ingest you see there is no table. Okay, now the stage is all set. So what are we going to do next? The next thing is to start your Kafka and set up your streaming ingestion process. Cool. So for those of you who are following the quick start, you can see that there's a template of your the Snowflake streaming ingest configuration file. So on my screen, I'm going to go there. Where am I? I'm going to go to Kafka. I'm going to go to config. And let's type in NTR. And here goes my SF Connect file, right? So if you look at this particular file, I have the name streaming ingest, the connector class, buffer count record. Okay, I was talking about you can define your record set, right? So you see it's 1. So that means for every record it is going to ingest. So it's not going to waste any time. I have my Snowflake username written over here, the one that I just created. This is my account URL, and this is my private key. So again, while typing in while pasting in the private key out here, please be mindful about the line breaks which will be there in your RSA file. You have your database name, which is the discover, schema name, which is ingest, account name, and these are few classes. Now, if you see over here, converted.schema.enable, this is false because on my particular system I have not enabled schematization. Now, if you enable that, you can turn this to true, and you can see that in action. So this is a quick and dirty simple setup. I think the code is over here. If you're following along with me, you can just copy it and create an sf connect or any other file names which suits you. But then please remember the configuration file that you create, right? So this file got created. So what is the next step? The next step, as per this particular documentation, is we have to start the zookeeper. If you remember in the this particular slide we were talking about, we're going to run zookeeper, broker, producer, and the consumer all in the same document, all in the same Kafka server.
Ritak, there
Yes,
are
please.
a few requests, Ritak, that the screen is not visible to a few folks. Could you please either increase the font or the size of the screen, please? Yeah.
Is it visible now?
I hope it is visible now. For me, it is, yeah, better. That's. I think it works. Yeah.
Okay. Fair enough.
Perfect.
Thank you very much for
old eyes
identifying. But
issue,
then,
not a blur issue.
yeah, it becomes
Too clumsy for you to work.
Yeah, that's fine. I'll manage. That's fine. So now, what are we going to do? We are going to start the Kafka server process, the zookeeper, and the rest of the things. Fair enough. So let's go back to our home directory and clear this up, right? And what we are going to do, we are going to run each process in each window. So the first thing that we are going to do is we are going to start. This is CD hands-on labs and Kafka, right? The first thing that we're going to do is start our Zookeeper process. It takes a little bit of time. While it starts, let me copy the command to start my broker, which is nothing but my server. So it's taking a little bit of time. It does take. Okay, I'm going to enlarge this as well. Did it start? I think it is, yes. Now I'm going to start my server.properties. There you go. My broker has started. What is next? Okay, now that my broker has started, let's go ahead and check, do I have any topics already created? How many topics are there? Describe topics, blah, blah, blah. We'll just do a quick check. Okay. So I have a command over here to check if I have any number of topics over here. Well, I do have, a particular topic created out here, which is called customer data topic. So who created this particular topic? So when I ran this lab just before coming over to this particular session, I had initiated the Snowflake Kafka connector, right? And the Snowflake Kafka connector automatically creates that particular topic on the background, and it also creates the target table. So let's do something like this. So we are going to, well, what we can do is so this is where we are instantiating the Kafka standalone properties with the SF connected properties, right? Yeah. So this is where I'm starting the Kafka connector. And the moment the connector is up and running, I'm going to quickly run back to my Snowflake window, wherein you will see, if I do a refresh, you will see a table has been created, right? So it's like, ideally you can create a table, but then you may not also create a table. It is intelligent enough to find out whether the table exists or not, right? And if I go to my channels, if you see, there's a show channels out here, right? A channel is also created, right? And the offset token is 0 because we have not pushed any data. At this point of time, if you go back to the quick start, it talks about how can you manually create some data. Now, what we're going to do is we're going to manually create some data and manually ingest into Kafka. For that, we have to start our producer. So how are we going to start our producer? Here is how we are going to start our producer. You can see Kafka console producer, the topic which was already there. And here is, yes, the producer is running and waiting to receive data. So what are we going to do? We are going to ingest the data. Now, if I go back to my Snowflake screen, you see generate records for manual ingestion. So what I've done is if you are logged into your trial account, by default there will be a database called Snowflake sample data. In case it is not, you just have to enable that. It's available to most of the users. And if I run this from the TPCH dataset, it gives me a bunch of records. So what I've done is I've already copied this particular record and I've pasted it here, on my screen on this particular window. I've already pasted it here. So what I'm going to do is I'm going to Control A and Control C. I'm straight away going to go to my Kafka producer and I'm going to paste it here. As I do this, if I go over to my Snowflake table, what do I see? You see on my Snowflake table, 200 records which I pasted onto my Kafka producer, they're already here. How much time did it take? Barely few seconds. If you would have done this with Snowpipe, how would you have done it? You would have copied these entire 200 records into a file. You would have submitted the file to an S3 location, wherein the Snowpipe streaming or the Snowpipe process would be listening, and then the moment the pipe arrives in that particular streaming location or S3 location, Snowpipe loads it into Snowflake. Now that's a time-consuming process. It would have taken at least more than 30 seconds or 45 seconds for this particular entire thing to be done with Snowpipe. But here we have been able to do that in seconds. Now there's something very, very interesting, because you see record metadata and record content. Now on the record metadata, this is nothing but it talks about the creation time, the offset, the partition, and this. And record content is actually the data that you have just ingested. Now, as I was talking in the previous section, that if you enable schematization, you can very well segregate this entire JSON string into different attributes, like the first attribute, second attribute, and the third attribute. But because we have not done that, I've prepared this particular query, right, which is just reading the variant data type. So you are able to read all the variant data types in that particular JSON string. Now, if I go over to my channel, this is very important, because for every table you can see the channels getting created, and on the channels you can see the offset, right, 399, and you have a row sequencer. You need not worry about these numbers. These are for internal usage of Snowpipe streaming. But then if you have multiple partitions, you will see multiple channels automatically getting created over here. And that is the message that I wanted to pass, that the order of records is definitely maintained within a channel, but not across channels. Well, now when I talk to my customers, the very often question that comes up, that how do I monitor my usage? How do I know how much of credits that I have burned with my now Snowpipe? People are aware about how to see the credits burned for my Snowpipe, but then how do I find out the Snowpipe streaming credits? So here's a view from the Snowflake information schema, account usage.snowpipe streaming client history. Now, if I run it, you will not be able to see the current usage, because it takes approximately 2 hours, around 120 minutes, for these views to be refreshed. It's not live, so the data that you will be seeing on my screen is something which I was it's like I burned those credits while I was setting up this entire demo. So over here, what you see is you can see the client name, you can see the Snowflake provider ID, and the events, the event types, and the byte size. Now, if you remember, in the beginning, I was talking about what are the different factors which adds up to the credit usage. It is your the clients, the event hours, and the credits, and the number of clients, which is your clients. So this query, don't worry about this query. This is all there on the documentation. So if you type Snowpipe streaming costs, you will definitely see this particular query. So I just copied it from the documentation for ease of use.
You're right.
Okay. So what you see is the number of clients, the event hour, the number of credits burned, the client name, and the Snowflake provider ID, right? So this is how you can, get an usage history of your Snowflake streaming. Well, I think I'm done with whatever I wanted to show you this afternoon, and let's go back to the question answer sessions.
So one of the query which team is asking is time travel option available on dynamic tables as well? I know that it's in private preview, but that's the query.
For the time being, it is not. But then, yeah, you can always have it. It's like, it's still a private preview feature. Things are changing every now and then. By the time it's public, let's keep our fingers crossed. It might be available.
Thanks.
There are
During
comparison questions, Rita, like questions around Snowpipe versus Snowpipe streaming, costing, which is higher, and those kinds of questions.
So, so the two scenarios are different. Let's step a little back, one step back. So if you have files coming in at not very frequent intervals, let's say one file coming in per hour, or multiple files coming in per hour at a definite interval, and it's very, very consistent, I think Snowpipe is your go-to guy, because but then if you are taking in data from a real-time source like a Kafka or like an IoT device or an edge device, which is throwing in millions of records per second, then you will definitely have to go to Snowpipe streaming. And Snowpipe streaming is cheaper in multiple aspects, right? So it's really not an apple to apple comparison, because Snowpipe has its own use cases, wherein Snowpipe streaming has its own use cases.
So one of the question, basically it's data ingestion process. If Snowpipe streaming fails, what is the rollback or any of those things which we can do in Snowpipe streaming?
Absolutely. So it's a great question. If you have a Snowpipe streaming configured on your Kafka, you can, so you remember I was talking about the offset. So if in case your streaming pipeline fails, the offset is maintained. So let's say the streaming pipeline fails at an offset level of 1000, and your streaming and your Kafka is still streaming the data, but you're not able to ingest it, right? Because your streaming pipeline has failed, but your offset is still maintained at 1000. So next time when you re-instantiate your streaming process, it starts from 1001, because it is intelligent enough to understand that the channel offset is it's like, it's maintained. That particular metadata is with Snowflake.
One of the question is Parquet data. So the team wants to know how do we can stream from Kafka topic itself. Do I need to stream the data of Parquet, or can I directly ingest Parquet from Snowpipe streaming?
That is correct. You can. There are different classes. If you go into the documentation, it has for Parquet, you will have to use a different kind of a class, a Java class. You will just have to add that Java class in your configuration, and it gets rolling.
Yeah, thanks.
Any other interesting questions? I created a Snowflake trial account on the Discover. I'm just reading now. The trial is going to go over. I think for this, you will have to reach out to the support. I don't think we can address this during the Discover session. Does the cost is
asking us a question? He's our data head. He's asking a question around Maven Central is reporting error not found. So I wanted to answer him that we can check the setup, etc. But yeah, we do not have a
I know. It's like, that is the primary reason why I had opened up this particular window on my screen, wherein you can use the Maven Central. So don't worry. Post session, all these reports, all these reference links will be available to you. Yeah, and I think that is the reason Farhan was saying that you have to log in with a alleged email ID, wherein you will get a notification that all these links will be made available to you. And yeah, apologies. The Maven Central link over here on this on the quick start, I think it has become outdated now. So the new link is here. It will be shared with you on a post the particular session.
Could you please share it on the chat window?
Okay, I
can. It's help.
Can I type? I don't think I have rights.
On the chat.
You can type on the chat. We can publish on Q&A.
Oh, okay. Yeah. Okay. Fair enough. Yeah, you go.
Type to everyone. Yeah.
I'm just looking at the Q&A. I don't have the
Yeah.
chat.
So there are two questions interesting. basically, Suresh is asking, how do we reset the offset, the Kafka offset? And another question is, from streaming, is there only Kafka? Apart from Kafka, any connectors, integration, support, maybe in pipeline are there?
Well, I'll take the first question. So again, going back to my screen, you can see channels. You can go ahead and reset channels, but then be mindful of the fact it's a very, very risky thing to do. So you should know what you're doing. You need account admin privileges to do that. You can go ahead and reset this particular offset. At any point of time, if you think that you want to reset your tables back to 0, you can drop the table and recreate it once more. That's the brute force method, but then you can always go ahead and change this particular offset. But yeah, it's a little risky for first time developer, but then if you're an advanced developer, feel free to do that. Okay, that's the first question. And the second question was anything other than Kafka. So as I was telling you, with the launch of our manufacturing data cloud, a lot of customers are interested about moving data from the MQTT brokers to Snowflake, wherein what we did is we were able to simulate that particular scenario, wherein you have an edge device which is listening to, let's say 100 odd IoT devices, IoT sensors streaming data to your MQTT broker, which can be EMQX, which can be Mosquito or anything, any open source sitting on your edge device. And on the same edge device, what you can do is you can set up your streaming ingest SDK, which is your Java library, which is not this Snowflake Kafka connector, right? Which is or the Snowpipe Kafka connector, which is your Java SDK. You can configure your Java SDK. You can host it on the edge device, which will be listening to your MQTT broker and pushing data to Snowflake. So that can also be done. So it is not only Kafka, but then with Kafka, you get a native integration, which is your Snowpipe connector. But then with your other brokers, you will have to use the streaming ingest SDK.
Thanks.
Any other questions coming up? When the metadata changes a source, the same needs to be manually replicated at the target in Snowflake. When the metadata is changed at the source. So I don't understand what exactly do you mean by metadata, Rajashekar? But then if you are talking about, the definition of your data set, which is coming in. So let's say you have, a record set or a record having 5 attributes coming in, and tomorrow if it changes to 4 or to 6, will this work? Yes, it is going to work. And with schematization enabled, it is going to work, in a beautiful way, because your applications can immediately see that particular change in your in your number of columns in your particular record without even changing your pipeline. And that is the beauty of Snowflake schema evolution. So have a look at it when it is in public preview. Will Snowpipe streaming be able to handle 400K streaming records per minute? Absolutely, yes. I have tested it out myself, and I can tell you, and this is the answer to Ratnesh Sawant. Yes, it will be. But then again, we generally don't talk in terms of the number of records. We generally talk in the volume that it can address. So as long as it is, within a gigabyte per second, any number of records, it can do that. XML, JSON, file data patterns I didn't find anything about it yet, to flatten to table process for Python. Well, I don't know what do you mean by for Python, but then flatten functions are available within Snowflake, the SQL world, and you can definitely use them to flatten your JSON and XML. I have 10K plus records ingested every hour across multiple accounts. Every hour I use Snowpipe for now. Will streaming be cheaper? Well, again, Danish, it depends on how you are getting the data. If you're getting the data in files and it is like, at an hourly event, then I would request you to continue with your Snowpipe and not look at Snowpipe streaming ingest. But then if this 10,000 records are spread across every minute and every second, it's like, it's not an hourly event. It's 10,000 records over the totality of one hour, then definitely streaming, Snowpipe streaming is going to be your choice. How exactly once is assured? Now that is kind of a product question. So on the screen, if you see, there are, there's a client sequencer, there's a row sequencer, and offset. So all these parameters come into action when we guarantee exactly once.
So one of the question from Jevin is on the dynamic masking actually for the Snowpipe streaming data and any PI compliance we can do on the streaming data itself.
Absolutely. So what happens is data comes in from your streaming sources and lands up into your landing table, which is, let's say you have your original values on your landing tables. What you do is you create another view on top of it, on top of your first landing table, and you mask, and you can use the dynamic masking capabilities in that particular view. And that view can be a normal view, it can be a dynamic view as well. So as I said, within the data engineering landscape of Snowflake, all the security and governance tools that Snowflake offers can be leveraged. If I'm stuck and I will be requiring help and mostly setting up Kafka things. I don't think you will need any help on setting up Kafka, because and this goes to Sachin Mittal, because the quick start is very, very detailed, and it's not only this particular quick start. There's another quick start on setting up MSK, and I'm sure it will be a very smooth work for you, because while creating this particular quick starts, we have taken enough time to detail out each and every feature and each and every step. Does Snowpipe use PubSub model? Yes. So Snowpipe streaming doesn't use a PubSub model. PubSub is mainly for the broker, but then Snowpipe streaming listens to the broker as a subscriber. Any automated notifications available for these pipelines? Automated notifications? Yes, automated notifications are, I think it's a private preview feature, or yeah, it is a private preview feature. Please explore that.
Yeah, just to add to Ritab, there are actually email alerts plus notifications.
That is correct. Yes.
In public preview right now, I think, Ritab. Yeah, but very, very good features to actually explore.
Yeah. Any other for failures and details about failures? Well, I spoke about failures in streaming ingest, that you can always trust your offset. You can the on failure, it stops there. If you re-instantiate that particular process, it picks up from the last last saved offset. That is how it takes care of in a streaming ingest process. But if you are talking about the SDK, then there Java SDK, there you will have to set it up on your own. You will have to manage your own offsets. In general, what is the life cycle of Snowflake features? That is a very, very difficult question to answer, because it all depends on the complexity of that particular feature. If it's a super complex feature, it takes time. If it's an easy feature, then we can go to private preview and then public within maybe a quarter. But then features like native apps, features like Snowpark, they did take a lot of time, because these are very, very complex in nature. Right? How to tackle 16 MB size of columns? Yes, for the time being, Snowpipe streaming has a limitation of 16 MB per column or per record size. I don't understand, Bhanu, when you talk about 16 MB limit of a column. I think you meant a particular record. So 16 MB is the limit as of today. Fair enough. I think we have covered a lot of questions. Are we on time, or we are okay to take a few more questions, Sarita?
We have a few minutes if you want to take a
Okay.
couple of more
Okay.
questions if you have time. Yeah.
In the target table, some of the inserts may already exist after streaming. Yes, in the target table, some of the inserts might already have exists because see, when we are talking about Kafka, things are very, very matured, right? It's exactly once delivery, blah, blah, blah. But then the moment we are talking about some other broker, let's say an MQTT broker, wherein you are working with a quality of service, you have the QoS level, quality of service levels at 0 and 1. 0 is like fire and forget, and 1 is like at least once. So the moment it is at least once, that means there is a possibility a particular record can be delivered to your subscriber more than once. And in that case, you will have to configure streams, right? The CDC mechanism based out of Snowflake. So this is nothing to do with Snowpipe streaming, because if I know the same record comes in 2 different channels, Snowflake has no mechanism to identify that the same record has come into 2 different channels or 2 different partitions. In that case, you will have to rely on Snowflake streamings. Can we use Snowpipe streaming for fixed length files? Yeah, definitely you can use it, provided you know that the metadata of that file. So it's going to be a schema on read. So on your reader side, you will have to govern the user with the definition of that particular fixed length, that where exactly the first attribute ends and where exactly the second attribute ends. Is there a way I can get email notification? Yes, you can. So that's what Sarita was talking about. Email notification is already in public preview. Please visit our website. All the documentation and details, how to set it up, are all there. Junaid, in the target table, some of the inserts may. Okay, we have already taken that question. Can we do recursive streaming using Snowpipe? For example, using regular expressions for matching files? Yes, you can. Absolutely, you can. Well, I don't understand what you mean by recursive, because this is a continuous process. So Snowpipe in its nature, it is never stopping. It is always running. But then, can you do a pattern matching on the files? Yes, you can. What if duplicate records are ingested? Will it identify automatically and ignore duplicates record set? No, it will not. So if you're talking about Snowpipe, no, it will not. Or streaming ingest, you will have to. So that's what I said. If a same record comes in 2 different partitions, Snowflake has no mechanism to find out that the same record has already come in the previous partition or in some other partitions. So you will have to set up streams for that. Any data monitoring tools inbuilt within Snowflake? There are no tools as such, but then we have state-of-the-art views or metadata captured within Snowflake. You can create your own, and you can create your own dashboard using Snowsites. So we have done that for multiple customers who were not eager to onboard a third-party monitoring tool. What we did is, with all our data available within the information schema, we created multiple views, and we were able to create a small dashboard within Snowsite and hand it over to them, and they were super happy. Please send me a copy of the resources at this. Well, we cannot email it to you like this now. As Farhan said in the beginning of the session, I hope you would have logged in with this valid email ID, eli@villarama@yahoo.com, and you will get all these details over there. What is the Snowpipe streaming cost pricing model? Vasudha Das, I think we have already spoken about it. It depends on multiple factors like the size of the records, the number of records, and the data types. Please visit our documentation for more details. And on my screen as well, if you see that, there's a query that is there which tells you the number of credits burned for that particular Snowpipe streaming ingest process. What if duplicates? I'm not going to talk about that. We have already covered that again. Can we ingest fixed width files? Yes, we can. Fair enough. Farhan, I think no more questions, and we are, good to wind up the session. Yep. Thank you, everybody. And you guys have been a lovely audience, great questions, great curiosity. And I would sincerely request you to go to this particular quick site, quick start. Take a look at whatever I have shown you today. And at the same time, take a look at Snowpipe for those of you who are new to Snowpipe, and you will see the difference or the benefits that Snowpipe streaming offers on top of Snowpipe, and you will be in a very good position to be an advocate for your customers. Yep.
Right. Thank you so much, Rhythm, for this session. We are exactly on time. We have a few minutes to spare, but that's always good news. We could always prep our audience for tomorrow. Tomorrow, ladies and gentlemen, we are doing data science on Snowflake. So if you want to know how you can use Snowpark for data science and machine learning, if you want to know how you can build your own feature store on Snowflake, join us tomorrow, and we'll take you through that journey. Now, with that, I'll wish you all to have a very good day after this, and I'll see you all tomorrow. Thank you so much, everyone.
Thank you, everybody.
Thank you so much, everyone. Take care. That's a wrap. Oh, that was a hard day. It had a big issue halfway through the day, honey. It all broke.